So, hello everyone. My name is Clemens. I'm responsible for everything that's kind of related to telling the story of what we do, so marketing. And then we have Henning and Hannes, who are responsible for structure of our team and our car, and mainly also what this presentation will be about, the monocoque of our new Sonnenwagen and also the old one. So I'd like to do a very small journey. So imagine you're in the middle of Morocco. It's 5 a.m, it's freezing cold, and we're there with a car we built in 2 years. We hope everything is working, but it is built up by students, so everything can always happen. And it's 5 a.m, you have to get up. We're 50 people, and when the sun comes up, we're allowed to charge. So everything is running around. We have to get the battery in, we have to get the car ready, and then we're allowed to charge. We have to set the angle of the solar array. Maybe you saw it already in the back. We can shift it so that we get always the maximum power out of every component. And then at 8 a.m, we're finally racing again, and every day it's hundreds of kilometers through the desert and through the mountains back to the ocean of Morocco. So what are we? We are 7 departments that are doing a lot of very different things. We have on the one side the technical teams, for example, the structure guys that are doing a lot of with carbon fiber, for example. We'll always have the chassis, the aerodynamics in the first place, the electrical engineering, driving strategy. And then on the other side, on the non-technical side, we have the sponsoring and the marketing. That's, for example, my job then. And then we have one big race. This is everything that happens, and that's why we build those cars. And you can see it on the right side of the slide. It's the World Solar Challenge, which is the biggest race. It's 3,000 kilometers from the north coast to the south coast, down to the desert of Australia. This is just a picture from us. You can see we're not 50 people on that picture, but you can see 2 very different solar cars. In the middle, we have the Covestro Photon, you also saw outside already. And on the right side, a bit at the corner of the image, we have the Covestro Sonnenwagen, which is a very different solar car, but works in the same concept. So what are we? As I already said, we're a student team. We're 50 people from RWTH Aachen and the FH Aachen in Germany. And we're founded in 2015. So we're right now not the youngest team anymore. We're still not that old. There are older solar teams in the world, but we're already building our 4th solar car at the moment. What do? We have the big race in Australia and want to always show what is possible with today's technology. Because if you look in the market, you don't see the limit of what is possible with electric mobility, with solar energy, and that combined. What are the challenges? As I said, the biggest race, the World Solar Challenge on the right side, 3,000 kilometers. It's a race you drive in 5 to 7 days. That of course depends on how good you perform. If you're very fast, you will finish the race in 5 days. And if you're not that good, or you have some, emergencies, you have to repair parts, which of course happens in the middle of nowhere, then you need maybe 6 or 7 days. Around the world, we have 50 teams, and they're all around from different universities in North America, South America, Africa, Asia, Europe. Every continent is competing there. And we have a lot of challenges which are stated in the regulations for the World Solar Challenge. Also, we have other races which are, for example, the European Solar Challenge. That's a 24-hour race in Belgium. And that's very interesting because we're building solar cars, but you can also race solar cars at night. Of course, we have a battery inside. It's not that big, so we're allowed to have 2 charging stops during the race. But it's a very different concept because we're not crossing a continent, but we're driving on a racetrack. This one also a former Formula 1 racetrack. And there's the last race, the Italian Solar Challenge in Imola. So that's on an actual Formula 1 racetrack. We've been there last year with the first race in Italy for solar cars, and a very, very interesting experience. So as I said, we're building the 4th solar car right now. So we have 3 ones we already have that raced a lot we can look back at. The first one is the Sonnenwagen 1. You can see on the top right side, it's a catamaran. So it's a bit like the boats, you have a tunnel in the middle. It has 4 wheels and a steel construction. And it was at the World Solar Challenge in 2017. And then next up, we had the Covestro Sonnenwagen. This is not catamaran, but the bullet design. So that's kind of the 2 concepts we have in the solar racing world. It was at the World Solar Challenge in 2019 and became 6th place after we had a crash. So 6 out of 50, still pretty good, I would say, with fixing a car in the middle of the desert with just building up a tent and well, one of the guys from our team 2019 said we can do a lot with tape, and that really is a thing. We don't have a picture with tape, but kind of everything is just full of tape. It is fixed again. The official said we're good to go again, and we finished in 6th place, so still very impressive. And at the European Solar Challenge with this car, we became 2nd place last year and the year before that. And then we have the last finished solar car, which is the Covestro Photon. With the Covestro Photon, we should have been in Australia in 2021. Then there was Corona, and Australia closed all the borders. So we had a different race, and we built that race kind of with other racing teams. The Moroccan Solar Challenge I already talked about. We became 5th place there. That's where you saw the picture from the first slide. And also last year we were very good with the Covestro Photon. We won the European Solar Challenge and the Italian Solar Challenge. So far, this is the European champion out there. And right now, from the beginning of last year, so 2021, we are designing and developing the newest Sonnenwagen, the Sonnenwagen 4, but more about that later, and a bit more about the Covestro Photon from Henning.
Thank you, Clemens. After Clemens summarized kind of our achievements over the last couple of years, I'd like to get more into a bit of a technical detail tour of our current car, which we also brought there and back. And it's not just the 3 of us who are here today. We brought a couple of more people, so plenty of people you can ask any question you like about our current car. Just to start off with some facts of the car, we are allowed to have 4 square meters of solar cells onto the car. We have an ultra lightweight carbon fiber composite body, which started off with this with the steel frame, and now we are onto like having kind of all the components except for the suspension that are made out of composite. So we achieved a weight much over or a lot over or under 200 kilograms. We are now aiming for approximately 160 kilograms. And the engine is also, as everything else, self-developed in our own small shop in Aachen. And we are trying to achieve an efficiency higher than 96% in the overall drivetrain, which is, I think, fairly impressive. Also, aerodynamically, we have a highly efficient asymmetric design here, which is a huge challenge when you're trying to start with we started with symmetric designs as, for the first car, the second car as well, and then we try it our best doing an asymmetric design for also side wind scenarios and a better compensation of everything concerning the wind. A battery, as Clemens mentioned, we're also driving at night sometimes, so we're allowed to have 40 kilograms of battery stored into the car. In this case here on the side where the point is opposing the side of the driver to compensate for the weight. Next up, I'd like to get into a bit of a detail of the regulations we are facing, which are inspired by the FIA, as you probably all know here. I picked out some of the main regulations that are important to illustrate one example. I'd like to get into further detail on the next couple of slides. We are allowed to carry 1 driver in our class, which has to be around 80 kilograms. We are only allowed to have 3 wheels or more, so no motorcycles allowed yet. Maybe next season, I don't know. Solar area-wise, as I mentioned, 4 square meters, we're allowed to use them, so we definitely use them. You won't go for less. You'd like to keep as much energy of the sun as possible. 40 kilogram of battery cells, in our case the LFP cells, and predefined driver cell looking like this, which I get into a bit more detail later on. So development goals-wise, I kind of picked out the 2 most important points for us. There are several more, for example, reliability or efficiency itself. We kind of have to try to always maximize the usable energy coming in from the sun whilst keeping or minimize cumulative resistance through the drag or roll resistance itself, and try to keep it as in an optimum. Here we kind of have a nicely illustrated picture of our in MATLAB built simulation that runs the sun across the day, or the sun across the light source, the sun across the day, shining onto the solar cells, and how efficient they are working over the course of the day, whilst keeping this very bad canopy, as you saw on the last picture. This is where the driver sits, and we're trying to keep the shadowing part here, seen here in the picture, as low as possible. So that's only one simulation we're doing out of the plenty, and this is also probably why we're here on this day. Clemens went through a couple of actually all of the designs we had over the course of the last year. So you saw them. I'd like to get into one more point, is that this is not only the case in our team. We have 50 teams from all over the world designing those cars, and we inspire each other for all of this. We kind of call this the solar family, trying to develop and push the boundaries of solar racing all over the world. So it's kind of hand in hand working with all of them and trying to work out which of those kind of end up those two designs, which one is the better one. And we are really looking forward to the 5th of June to reveal the new car that we are worked on for the last 2 years. Very sad that we cannot show pictures of this one, because this is the one that we were into technical details. We can only tell you something about the old car that is also here today. So really looking forward to this date. Okay, so now some technical parts itself. I try to draw it into a triangle here with opposing sides of limited space, provided to do a very good aerodynamic shape design, which is very important because we are trying, or the challenge itself takes place on a very straight, 3,000 kilometer straight Australian road with a lot of sun. So aerodynamic design is very important. Also very important for us was the safety aspect. Here, as an example, the monobox, which includes many steering components and also is crash resistant to 5G, where the driver sits here on the side. So that's also a very important aspect, which comes in quite narrow sometimes with the limited space factor. Lightweight, mainly driven by the material choices. We are lucky to have a lot of sponsors there who help us have the best results there. We do a lot of material testing by our own and try to keep everything then coming in together to have a very good car. I'd like to get into details to one example on how we try to have all the data coming from all the departments, from all the sides, coming along to really develop one thing, a very, very efficient car. I'd like to get back to the one thing here. For example, I chose to take one parameter. We have plenty of them. I just happened to take the one for concerning the back angle of the driver. So you sit in the car, you could sit straight or very lean backwards, and we have to decide, okay, what's the angle we're trying to choose? And very many factors taking in account to there. So maybe the comfort of the driver itself, it does change when you change the back angle. The shadowing of the solar cells change. The canopy gets bigger. If I sit upward, I shadow all of the cells. We don't want that. The car gets longer, so the driving stability gets worse. If you do it too long, the aerodynamic changes as well. So you notice that a lot of those small parameters we change have a huge impact of the design of the car, and we have to deal with seven technical departments that work in handy, and we have those optimization loops where we try to come with all the departments into each other, gathering there, and try to develop a very, very efficient result there in the end, that have an energy consumption model at the end and try to reduce it to the very limit. And to achieve something like this, we have to have a very good design environment where all the different departments can work on their own stuff, and we all understand what they are doing at all time, and try to have the level of design kind of on the same level, trying to rise to the top, not one department trying to be very hard working in the beginning and another one not, where we try to have it in one level. So we try to find a software solution where we can implement all of this to really develop a car where all of the departments, as I told you, is very important that they will all work together, develop a car to the full piece. And now you see it there standing in the back, and I really would appreciate if you have a detailed look there in the back. Now to more software stuff from Hannes.
Well, from my side as well. Thanks for having us. From now on, I would like to show you what we are using in our software environment, and we decided to go for SimCenter with plenty of simulation optimization opportunities. One of them is GRM, and that's why we're here. You also exist in part in this ecosystem, and we're very, very happy to be able to use it. So in all of this, we try to, as it was already mentioned, bring all the technical departments together, be able to work parallel with all our team members to achieve in this very short amount of time in designing a new car. And this is really what we're aiming for. So As already mentioned, Henning and I, we developed the the next car monocockpit. And so we are part of the structure department. That's what I want to focus on, because I know something a bit more about it, and then instead of talking about aerodynamics and stuff. But for example, here you see how much detail we go in the end. So you see here one little tiny bracket, which is just supporting the solar array in the moment of charging in the morning or in the evening. And so we put even in those parts a lot of effort. And the question is how we can optimize this in a sufficient amount of time. And one pretty reasonable example is the trailing arm of the car you see in the back. Just have to dive below the car to see it later. I can show you where you can find it. But we use definitely GRM and the OptiAssist optimization to improve the design. And this helped us quite a lot. We were able to reduce the weight by around 70% compared to a solution we came up in the first place. So pretty impressive. And that's why we're also using this software. We all doing this to move from different software and optimization solutions to bring this all together in one digital twin solution. We're not that far yet. It's always tough to start with a new team of around 60 members to really dive into a new topic and bring everything together, and then building a digital twin is quite tough. But we always looking for that and trying to give hands over all our knowledge to the next generation. And one step we were able to do this season further than in the last was that we were also able to optimize the laminate of the next car. So this is kind of the first glance on what we're building right now. We were able to reach our design goals, the stiffness and displacement limitations we were facing, were able to find a reasonable solution with a pretty nice weight and safety we can provide in the end. I think some of you definitely know about the system of this. So in the end, the OptiAssist is providing us like a recommendation where to place the plies, what thickness we have to expect, and which are the most critical areas in our components, and this helps us a lot. One other thing is something that we use just in parts is the fiber orientation optimization, where we are looking for the principles in the stress results to find the actual best orientation for the fiber. And in this case, you see here, it's like the side impact on our car, which is like based on the numbers by the regulations actually. And then in the end, we are also always have to tackle the different, as Henning already mentioned, the different parameters and what can we achieve next. So in the first place, we are really looking for large design parameters, which influences a lot. But in the end, we're, as you have seen, also go into very detail and try to optimize till the last bracket we have to place on our car. To sum up all of this and give you some nice pictures we made the last years, we bring in a video to you which shows you maybe some of our enthusiasm into the project and the fun and the enjoy we all have doing this full time, basically the last weeks. So enjoy and. Yeah, thank you very much for your attention.